Hello, everyone. Welcome to our Austin Energy Green Building Seminar, Mastering Manual J and COMcheck. This is our bi-monthly seminar series highlighting topics important to sustainability in the built environment. Before we dive into today's topic, we'll start with a few announcements of local events and put the direct links in the chat now. Our AEGB e-learning platform offers on-demand courses so you can earn continuing education credits at your convenience. We upload recorded webinars and other virtual learning resources like tours, workshops, and case studies. Log in to register and see what's new. Our annual Green by Design workshop is almost here. Join us in person this year to learn about building practices and technologies that can help make homes more efficient and comfortable while reducing maintenance costs. Materials and light snacks will be provided. Register now to attend 1, 2, or all 3 of these free Wednesday evening sessions. Austin Energy, Austin Development Services, and Austin Technology Services invite you to visit with us on April 9th at Austin Energy headquarters. Bring your input and get all of your questions answered in one convenient location. Register on the Speak Up Austin website. The Humid Climate Conference is at Austin Central Library this year on May 4th and 5th. Learn what you need to know about the energy transition, the refrigerant transition, the carbon transition, and important developments underway in high-performance enclosure design, MEP engineering, and the policy landscape. FIAS and AIA CEUs will be available. Learn more and register on their website. Our residential rating team is updating the single-family and multifamily ratings to incorporate the latest code updates and support the climate equity plan. Starting May 1st, you'll be able to provide comments on our Speak Up Austin pages. Mark the date and look for email reminders as we approach this timeline for your input. Registration for the May seminar is now available on our website. We'll explore electric equipment for job sites. Speakers will discuss current trends, new technologies, and the benefits for climate and worker health. Go to our Learn and Connect page for more details and sign up. Lights Out Texas encourages building owners, businesses, developers, and homeowners to help protect migrating birds by turning off all non-essential nighttime lighting on buildings and other structures from 11 p.m. to 6 a.m. Check out the Texas Audubon website for more details. This seminar is being submitted for AIA learning units, GBCI continuing education hours for lead professionals, and AICP for all those that attend this entire webinar. All certificates will be emailed. A follow-up email will be sent with links to the recorded webinar and other resources. It will take a little extra time for video editing this seminar. We will be adding this to our e-learning platform as well. Here is the AIA quality assurance slide. These are the learning objectives for our seminar today. If you have any questions during our speakers' presentations, be sure to use the Q&A window throughout the seminar. We've scheduled time at the end of the seminar to discuss them, but for any questions we don't get to, we'll get those answered after the presentation and send them with our follow-up email. Today we'll discuss mastering Manual J and COMcheck. Designing insulated buildings with proper mechanical equipment and lighting is key to optimizing energy efficiency and comfort. This seminar explores practical approaches to achieving those goals while meeting energy code requirements. Our first speaker is Chris Morin. Chris is a self-employed HVAC system design trainer, consultant, and coach, serving distributors and contractors across New England. He holds a Bachelor's of Science in Business Management from the University of Phoenix, is a certified professional coach, and has a Massachusetts Master Sheet Metal license. His HVAC journey began early, carrying tools at age 16 and graduating from Minuteman Regional Vocational High School in Lexington, Massachusetts. From there, Chris entered the U.S. Marine Corps as a refrigeration mechanic, serving 2 tours in Iraq and emerging as a young leader. In 2012, while working as a tech instructor, Chris realized he had more to share about his experience in the HVAC industry than just what those classes were providing an outlet for. From that point, he authored the successful HVAC Frog blog. Today, Chris is an ACCA Epic residential system design instructor, known for delivering practical, field-tested insights to building officials, distributors, and contractors alike. His work includes classroom teachings, field consultations, and deep dives into system design, quality installation, and diagnostic strategy. Please welcome Chris Morin.
Thank you so much for the very nice introduction. I really appreciate it. I'm so excited to present today. Obviously, I'm not from the Texas area. I think you're going to find a lot of these principles are definitely work around the country, but I did tailor this presentation to Austin specifically. So like mentioned, I started in the industry when I was very young, and system design used to be taught by manufacturers and distributors back then. And we've gotten away from that over the years. So my journey through the trade, even during when I was in the Marine Corps, I was a refrigeration mechanic. I found that some of the basics were skipped, and there wasn't necessarily the right people to answer those questions. So as I continued, I was able to meet a lot of the best and worst contractors around New England. And my business now, basically, I teach contractors what really works. And it starts with system design. So this is going to be a very fast-paced 30-minute mastering Manual J class. And I am going to hold on for the last half an hour for those that do have questions about this, that put them into the chat or hang on to the end, okay? So fast-paced. I promise not to read too many slides, but what you do need to know is Manual J&S is code. So in your 2024 IRC, that's the residential code in Austin and throughout the country, and this goes way back to like 2015's version. It's the same code reference, 1401.3. Heating and cooling equipment shall be sized in accordance with ACA Manual S or other approved methodologies based on building loads calculated in accordance with ACA Manual J or other approved heating and cooling methodologies. When I teach this in person with contractors, I like to ask them, what are some other approved methodologies? And pretty much nobody actually comes up with any, but we all know what methods contractors have used in the past. I love to joke about the eyeball method, Manual E. That's that document on the right of my screen here, where you cut out a size of a house and you stand across the street, and whatever one it lines up to is the size system that needs to go in. Here in the Northeast, we have a lot of wet heat, and we do the same thing with fingers. We'll cover up, that's a 3-section boiler or a 4-section boiler. And those that have ever heard of these are probably having a good chuckle right now. And what's just as funny to somebody that knows how to do system design is square feet per ton. Yet that is probably the most obvious way that contractors try to size systems. And it's unfortunate because it leads to a lot of typically oversized units that have trouble keeping up. And here in Austin, you have a lot of moisture problems. So an oversized system that short cycles is never going to remove all those latent gains. So it's really important that we focus on sizing, particularly around the cooling side. But of course, in heating, because you do have a lot of heat pumps and dual source systems in the Austin market, I think you're going to find there's a handful of things that impact the heat loss and heat gain the most. And that's what I'm going to try to cover in the next 25 minutes or so here. So when it comes to heat loss, the actual temperature difference that you're designing around makes up about 75% of the heat loss. And usually that can easily be calculated with an Excel document, right? You just need to know the resistance, so the U value of the wall, the square footage area, and the temperature difference will give us heat loss, right? Unfortunately, what this doesn't include when you use some of the simple calculators is infiltration or the air exchange. And what ends up happening is if you use some of these simple calcs or rules of thumb, you could be off easily by 25% when it comes to heat loss. That doesn't sound like a lot, obviously, for Austin, because we're focusing on the cooling side down there with air conditioners and heat pumps. But when you do need it, if you didn't take into account the 25% that you needed, it's going to have a problem keeping up, right? and it's obviously more magnified in the cold climates around the country. When it comes to cooling, you'll notice about 60 to 65% of it is probably solar heat gain, and maybe even more depending on new construction and how much glass is going into those new homes. So air infiltration does actually take into account probably 15, maybe even 20% of your heat gain. Temperature difference across those, because we typically design to a smaller temperature difference in cooling versus heating versus outside to inside, ends up making up a much smaller sliver. But we also, when we talk about cooling gains, we have to take into account the internal gains. So these are the things that impact the load the most. Don't get me wrong. There's probably 30 to 40 different inputs that go into your load calc software. And I couldn't possibly teach all of that in 30 minutes. I just want to focus on the important things that impact the load the most so I can get some details across for you guys. So what you need to know, because everybody's busy, is because this is building code, when you pull a permit to replace a system or install a new system, you need to provide a load calculation and equipment selection across the board, right? If you're doing a new duct system, you most likely have to provide manual D duct sizing information. And when I say ACA manuals, if you're not familiar, if you're not in depth in the heating and air conditioning industry right now, you may not realize they're actual manuals. That's what the software is based on, right? There's tables and appendices, and each manual has a different book, right? So manual S is equipment selection, manual D is duct design. And this process was developed over decades of trial and error and trying to figure out how a system can be designed. I had to smile. I started teaching this class about 15 years ago. My daughter right there, she's going to be 16 on Thursday. So I can tell you that I've already replaced my copy of Manual J since that picture. I took that with an old BlackBerry or something. But when she opened up Manual J, super disappointed when she was like a year old. There was no pictures. It's not a front to back read book. If you ever purchase an ACA manual, always read the appendices first. That gives you guidance, and it's going to explain all the examples and tables that they're walking through in the rest of the book, okay? So just a little fair warning there if you ever buy one of these. And keep in mind, Manual J is, we always say it's the first step in the system design process, but in actuality, you have to have a good idea about system concept first. That's Manual RS. And then, of course, the process goes on from there, right? And today I'm focusing on residential Manual J, not commercial load calculation Manual N. It's a different design process with different procedures. So keep that in mind. Today's really focuses on single family and multifamily residential. So first off, the thing that impacts the heat loss the most, and probably the cooling gain significantly more than here in the Northeast, down in Austin, you have to use the outdoor design conditions based on table 1A in ACA Manual J. So in heating, that means your outside design temperature is 30 degrees. In cooling, if you use table 1A out of ACA Manual J, it's actually 98 degrees. And Austin Energy has a building code amendment to size to 100 degrees, not 98 degrees. So 98 degrees represents the 99% design temperature, meaning 99% of the time it's 98 degrees in Austin or less. Only 1% of the year, when you add up all the hours it's over 98, does it add up to 1% of the year. So 3.65 days when you add up all the hours. Now, of course, that could be split over months, right? Because it's only, 99 or 100 or 110 for an hour, right? So that's 1 hour. It doesn't measure how extreme that is above it. It's only the number of hours above it. So when you design to 100 degrees, it's actually slightly higher than the 99% design temperature. But that's what you should be designing to when it comes to cooling for your building code. Now, if you deviate from that, it's obviously going to oversize a system if you size to a temperature larger. You definitely don't want to deviate from the indoor design conditions whatsoever. So in the International Energy Conservation Code and your building code, you actually have to size to 75 degrees for inside design temp and cooling, and 70 degrees plus or minus 2 for heating. Most people just actually size to 70. They don't go up or down on that indoor design condition. What I want you guys to know and be able to explain is why these design conditions, because every homeowner is probably going to say they want it to be 67 in their house, right, in cooling. And it's just not possible with residential systems. And it does not allow room for drift under the other 98% of the design temperature year, right? So if you size to a maximum temp, we're in this case at 100 degrees, 99 point something percent of the year. We're oversized 99% of the year. So when that system needs to ramp down, hopefully it's variable speed, it needs to be able to still maintain in this comfort zone on your psychrometric chart right here. So this arrow is actually pointing to 75 degrees and 50% relative humidity. And this area is what's considered the comfort zone. I'm not going to go into a psychrometric class because I don't have enough time today, but sensible temperatures on the bottom, these curves from bottom left to top right are relative humidity. I'm pointing to 75 degrees and 50%, and you'll see this gigantic shaded area. This shaded area represents where most people in the United States will be comfortable, comfort zone. So this actually allows room for drift under mild conditions. So if it is, let's say, 110 degrees outside and the system can't keep up sensible temperature wise, we're going to continue to run the system and remove moisture. And it might be 77 or 78 degrees inside, but 40% relative humidity because the system's been running all day and we're still within that comfort zone. That's an extreme situation. On the mild situation, when the system is oversized and it short cycles a little bit, it might be 73 or 72 or even as cold as 70, but it might be 55% relative humidity inside, and we're still within that shaded area and we're comfortable. And of course, the same thing happens in the heating season. If we can't keep up because it's below our design temperature, we can add humidity to feel more comfortable, right? We turn a humidifier on. Or, of course, a system's going to short cycle us when we need it. If the system's running really long, it's going to get drier and drier. We might need to add humidity in order to stay within that comfort zone. Also, which is really important for your climate in Austin, is if we run the system too cold, it is quite possible we're going to change the properties of that air to where a device that shouldn't be below the dew point of the air reaches that. And we would end up getting moisture on the inside of windows or inside building cavities. And obviously, when it's cold, dark, and wet, creates that four-letter M word that I'm not going to mention on the recording here. So really important. We want to stay within those design conditions so that way we don't bring building materials below dew points as well. All right. So it's really important that we look at the health and safety reason why those design temps on top of comfort. All right. Now, on to the next thing, infiltration. This is really important. Infiltration is determined by the air changes per hour and the floor area or square feet within Manual J. Keep in mind, this is not an ACH 50 number that's in there. Most software, if you enter an ACH 50 number, it's going to do the calculation based on much less wind, right? So the numbers you'll see in these charts are much lower than what you would normally see for code purposes, like less than 3 ACH for 2021 IECC numbers, right? Keep in mind, if you do a blower door test on an existing home, you'll get really accurate numbers and you can enter that into your software. If you don't, you're going to have to take an educated guess, or if you have a new construction, you need to know what the target is, right? So for Austin, you're typically working with standard construction homes is going to be set for semi-tight. And that's because you have a target of 0.22 air changes per hour in the summer, 0.41, which is accommodating higher wind, in the air changes per hour in the winter. If you're going to use a net zero house or more extreme construction, you're going to be setting your construction quality to tight. If you have a target ACH, you can just enter that though, right? Keep in mind, for existing homes that are going to be weatherized, you can see it can drastically change a loose house all the way up to average if you weatherize a home that isn't tight enough to require ventilation at that point. So really important, you need to know what you're looking at and what those set points are going to be when you're doing your load calculation. I've seen in the Northeast that heat loss and heat gain drastically change by 15 to 25% by air sealing and insulating a home. So just simple weatherization, which is usually covered by a lot of utility programs, will drastically change your loads. So if you're going to be doing that, you need to do the load calc with what the conditions are going to be. And for tight construction, which is typically new homes that are close to net zero, you're talking about meticulous air sealing. All vents have backdraft dampers, and there's no recessed lighting that could create excess leakage. The range hood in the home has less than 150 CFM, and any combustion air is direct vent. So you'll notice very easy to control that envelope in this instance. Most newer homes fall into that semi-tight construction, and this is guidance that I'm showing you right out of Manual J. Average construction is reasonable air sealing. The vents still have backdraft dampers and the same size range hood. There's no recessed lighting, or if there is, there might be boxes and it's sealed because they're not halogen, they're LED or something. So there's minor leakage, and there's like no envelope openings for combustion air for like fireplaces and stuff, right? So you can easily air seal or weatherize an existing construction home a lot of times up to average. Don't get me wrong. You're looking at my home office here in Upton, Massachusetts. I live in an 1880 Victorian. We can't air seal our house up to average, unfortunately, because the square footage versus the leakage and access to it can't get it there. Of course, semi-loose is between average and loose, but most loose homes are unweatherized. They're built before 1950, and they might have envelope openings for combustion air. They might have a lot of recessed lighting, which causes leakage, and maybe windows and doors that don't even have an NFRC rating because they're single pane wood frame windows, right? I don't know that you have a lot of that sort of thing in the housing stock that's down in Austin. And if you do, hopefully it's being weatherized and is being brought up to average, right? So we talked quickly about the impacts on heat loss, which were very simple: temperature difference and construction quality, right? But when we look at heat gain, we actually have to take into account a lot of other things in the calculation, including the direction of glass, what's putting off heat inside the home. It's a much more complex calculation, which requires Manual J version 8 software. It's approved by ACA. So the thing that impacts the heat gain the most is your windows, your fenestration. And if you have existing construction, you're just identifying what's there. The materials and what you're identifying is going to reference a chart to come up with a U value and a solar heat gain coefficient. Okay, you need to identify the framing material, the glass type, if it's clear or low E, right? And if you have more recent construction, you most likely have a window that has an NFRC sticker in it. You can actually take a look at that NFRC number, go to nfrc.org, type in the number, and get the actual information. Just keep in mind, if you're installing new glass, you need to identify the U value of the actual glass that you're installing, right, for that new construction home. And your solar heat gain coefficient should not be above 0.25 for Austin. That's the building code. If you have an NFRC number, you can plug that into the directory search, and you can see on the right-hand side here, we can actually get the real solar heat gain coefficient for that number if it's rated. If it's not rated, you're going to end up referencing those charts I was talking about. And it really helps if you're doing a site survey to make sure if the window has a low E coating or not. I've seen this impact the heat loss and the heat gain by 10 to 15%, depending on the number of windows and the size of the glass. I personally use this low E card from EDTM. It's very low cost. I think they make 2 different versions of it. Might be $100, but super useful in order to make sure I know if there's one film for low E or both of those panes have a film, if both are coated with low E. All right, so we talked about the glass itself. We still need to touch on shading. So you need to make sure on the inside you don't assume that there's no blinds if it's a new construction home, right? So typically, at least the bedrooms and the bathrooms are going to have some sort of shade, unless you're in the middle of a ranch and there's just nobody around, right? Then it's quite possible the owner may not be operating with shading inside. Also, don't forget about exterior bug screens. This is really important because it does deflect a lot of the sun and the solar heat gain. So you need to cover, if it's an operable window, if I have 100% bug screen or just 50%, like what's shown in these double hung windows here in this picture. If you don't know what the shading is going to be, the standard in Manual J is to use blinds half drawn at 45 degrees with a medium shade, all right, medium color. So if you're doing a site survey and there's existing drapes, you enter drapes. It's very, very easy when you already have a house that's already being lived in. All right, so let's move on to internal gains here. Really important for internal gains, the number of bedrooms plus 1 is how many people you should be putting within that home or residence. The only exception in Manual J for additional people is if you have full-time occupants, like elderly guests that are living there in a room that is not a bedroom. That's the only exception. Keep in mind the people should go into the rooms that they're going to be in during peak demand. So typically, like my daughter's a teenager now, so she's probably the exception. She's in her bedroom at 4 or 5 p.m. in the afternoon, but most people are not in their bedrooms. They're in a living room, maybe in a kitchen, in a home office. That's where you're going to put them because those gains could impact the airflow and the duct sizing going to those spaces or the distribution with ductless systems. Now, when we talk about appliances, also giving off heat within the building, there's some standard scenarios that are built into the software, and this is where I see a lot of people short themselves. If you're doing a block load, don't just use scenario number 1, which is enough for your kitchen. So refrigerator with a range is 1200 BTUs per hour. That's always the default in most software. If you're going to do a room by room load calculation, that's enough to put in the kitchen. You should be adjusting for others. Scenario number 2 for a block load includes a dishwasher, a washer, a vented dryer, and standard electronic equipment and lighting that's on during peak demand, right? 4 or 5 p.m. And that's 2400 BTUs. However, most new construction homes have an additional refrigerator or a freezer on top of that, and or a wine cooler that's fairly large, always putting off some heat. So therefore, scenario number 3 is probably more likely what you would see in a lot of new construction, larger square footage homes. Typically in Austin, I believe the building code looks for somewhere around 3,000 BTUs per hour or less on internal gains. But if you have a reason to add, make sure you add to those spaces. Very common, you might have some ceiling fans. If you didn't realize, ceiling fans add about 250 BTUs per 75 watt motor within that space. If I have 2 ceiling fans in a living room, that's 500 BTUs. That can make a difference in sizing the runs on a duct system. So just make sure if you're doing a room by room load calc, you're making those adjustments to the correct space. And there's guidance within Manual J, and sometimes it's surprising. Sometimes you'll see a large family using TVs and stereos, computers, and laundry during mid-afternoon in the summer is an additional adjustment of 1400 BTUs for that load. So really important to not make a stock list of every light and every appliance because, the toaster's not on all the time. It's not going to be on at 4 o'clock, right? But you have to adjust for what will be on in the correct spaces. Now, all of these inputs I've been talking about, plus like 30 others, you're going to enter into ACCA Manual J version 8 approved software. There are many different types of softwares out there. I personally have used RightSoft for over 20 years. I also helped develop the Conduit Tech app with that team. So that uses LiDAR in order to scan an existing home. If you like worksheet styles where you list a wall and then the glass and the door and whatever else is on that wall, I think you'd probably like AdTech or Elite. Carmel software is app-based. It's very simple. It's easy to do a block load. It's much tougher to pull the information out and do a room-by-room load calculation, but it is ACCA approved. And what I can say is Amply has very similar functionality as Conduit Tech when it comes to LiDAR capability and using an iPad Pro. But what I want to point out, actually, last month, COMcheck just released an update, a full design suite that uses the best of Conduit and Amply and the best of RightSoft into one software. It's really awesome. I'm going to be switching over. It includes manuals J, S, and DEED. You can actually take a LiDAR scan with their app, or you can import a set of plans and do everything on the web-based browser. So I'm really excited for it, including drawing ductwork, and they have a bunch of equipment tables built in. Not an advertisement, just trying to tell you there's some really nice software making your job much faster and more accurate out there these days. Key here is make sure you do an aggressive load calculation, which means you don't manipulate outdoor or indoor design conditions. You always want to take full credit for efficient construction features like overhangs. I know I didn't get too deep into this, but when you build a house in Austin, there's a lot of homes that have large overhangs to provide significant shading, which reduces the cooling gain. If your overhang has at least a 2-to-1 ratio above the window, right? It's coming out 2 feet and it's only 1 foot above the window or more, then you're going to include that overhang on that fenestration because it could significantly reduce the load by 1 to 2 tons sometimes. And then make sure you don't apply any of your own safety factors already, because the process allows for slightly oversizing when you go to equipment selection. And the software has to round all these devices as you add it in, right? So the decimal points will go on forever. So when I was trained by Hank Rakowski years ago, he said that when they're approving software, there's already about a 20% oversizing factor built into an aggressive load calculation. So if you round up or you manipulate design temperatures, you can see how this process could get really out of hand. All right. So be aggressive, really important. I'm going to leave you with this. Quick story from the Marine Corps. I was taught how to do land navigation at night at Camp Geiger in North Carolina. And this is after boot camp. We're already Marines, but we have to all go through combat training. And the deal was, you walk into the woods, they give you your azimuth with this. Trust me, I'll bring this back to HVAC in a second. You walk into the woods with a buddy, and when you get to where you need to go, you open the mailbox in the middle of the woods. It has glow in the dark numbers, and it tells you your next azimuth, and it's a course through the woods. And they do it at night so you can't follow landmarks, right? And I was trying to get through the process faster than I should have, because the deal was if you make it through the course, you get to actually get some rest. You get to go to sleep. And we were very sleep deprived during that training. So skipping a couple steps, we were caught. The sergeant in charge asked us what we were doing. I said, I really want to get through this. I'm keeping it clean here for the recording. And he gave me the best advice, which when I was 19 didn't seem like much, but he said the time to have the map is before you enter the woods. And that can be applied to a lot of life lessons, right? But this really pertains to HVAC, because I could say that your manual J is your map. And the time to have that map is before you select equipment, before you install it, before you run your duct work, before you have comfort problems, right? Like the map doesn't work if you try to make it fit for what's already there. If you have the map, you can get to exactly where you need to go in the most efficient, highest profitable manner. Okay. So I'm done as far as land nav and the United States Marine Corps. I'm going to stop sharing my screen and pass this over to the next portion of your presentation. If you have questions, please, I'm going to hang on towards the end, and I'd be happy to address them when it comes to ACA Manual J.
Thank you, Chris. That was great.
No problem.
Our next speaker, Rob Salcido, is a senior engineer with the Pacific Northwest National Lab as part of the Building Energy Codes program. Rob leads the residential codes analytical team, where his work focuses on the development and implementation of residential energy codes. In addition, he co-leads the software development team responsible for the ResCheck and COMcheck software. Rob serves as a member of the International Code Council Residential Consensus Committee, as well as the ResNet SDC 300 Calculation Subcommittee. Prior to joining PNNL, Rob spent 5 years as the principal with Salcido Solutions, a consulting firm specializing in software design, building science, energy modeling, building energy analysis, and residential energy code development. Rob holds an MS in civil engineering from the University of Colorado at Boulder. He is also a registered professional engineer in Colorado. Please welcome Rob Salcido.
Thank you, Chris. That was a great presentation. Hopefully I can match up. My name is Rob Salcido. I'm with the Pacific Northwest National Lab as a senior engineer. I am part of the Building Energy Codes program, and I am technical lead within the program for the residential codes. And also, I am a developer and contributor to the COMcheck and ResCheck tools. So I kind of have two roles within the lab. Excuse me. So similar to Chris's presentation, we're going to get a high level overview of COMcheck. This is typically could be a 2 to 3 hour demonstration for a real deep dive into the software. So we're gonna keep it high level, gonna walk through some slides, and then we'll go walk through the kind of the inputs and how we've structured COMcheck for code compliance. So first, where does COMcheck fit into the compliance process? COMcheck is a commercial building code compliance, energy code compliance tool. So it starts at the very beginning of the compliance process where you capture a builder, architect, designer takes all the information, building specs and design specs, and inputs them into the compliance tool. And there you can determine based on the code edition, location, building type, does this building meet all the mandatory and prescriptive requirements of the code? And when successful compliance is demonstrated, that goes all the documentation, the reports, checklists go to the plan review team, where they can verify, as part of the documentation package, that yes, indeed, this plan this building as designed does meet the energy code compliance requirements. And then after permits are obtained, there's an inspection checklist report that field inspectors can use to go through in various phases of construction to verify that the as-built building is meeting the requirements set by the energy code. And so within that complex, the compliance options, there are various options. There's purely prescriptive options, there's a performance options, and then there's chapter 11 or the EPG method. But this, for COMcheck, we do a kind of a variation on prescriptive. So the HVAC, service water heating systems, power, lighting, and fans, ventilation, there are mandatory requirements that COMcheck is verifying based on the inputs. For the envelope component that we do, COMcheck will run an envelope trade-off option. This could be a simulated performance or a UA type of methodology, depending on the code and the year. And then we verify that envelope based on that compliance. And I'll explain that here, where within the COMcheck software, COMcheck can certify compliance for various codes from ASHRAE 90.1 standard, starting in 2007, all the way up to the 2022 version, which is the latest we have in the software. 2025 will be coming out this year, and that will be implemented before the year is out. So we'll be up to date on all the 90.1 standards. For the IECC, International Energy Conservation Code, we have COMcheck covers 2009 IECC up to the latest 2024 IECC. So each one of these codes have changed methodologies to verify envelope compliance. So the earlier 90.1 codes use an Appendix C methodology, which is a simple trade-off methodology. And the more current 90.1 standard use a full Appendix C simulation performance. So that we run a simulation, an Energy Plus simulation, to verify that the proposed building is performing better than a baseline building built to the mandatory requirements of the code. And the latest IECC methodology runs a component performance alternative, which is basically a UA methodology that's showing that the thermal performance of the envelope, proposed envelope, is better than an envelope of the same building but built to the IECC levels. So and in addition to the national codes, there's numerous state codes that have variations on the national codes, maybe, or sometimes have just adopted different appendices, and we've implemented those codes as well. So lots of variation on which codes can be selected. So kind of alluding to Chris's land nav example, is what information is needed before you start the process of building the COMcheck project. So some of the minimum information you need is the energy code edition. That's the big one. Which code are you trying to is required for compliance based on the location and building type. Then the location, and then we get into the details. It needs all the information on the envelope assemblies, R values, framing factors, and on and on. Insulation R values, fenestration performance data. Newer codes are starting to require thermal bridge data. How are the thermal bridges being addressed in the building? There's also interior and exterior lighting, space heating and conditioning, service water heating. And now with newer codes, especially 90.1 2022 and ICC 2024, there are renewable energy requirements, or if they cannot be met, what exceptions are being detailed. And then energy credits, we'll talk about those a little bit more, is how are additional efficiency requirements being met, and how, and so those have to be selected to meet the number of credits required for the building. So COMcheck works on a kind of a top to bottom, left to right flow, just in data entry. So we start with the project, move to the building envelope components, then there's lighting, mechanical, and if required in Lure codes, renewable energy and energy credits. And then finally, you can get to the checklist requirements and the reports. And we'll talk about each of these stages as we walk through the demonstration. To access COMcheck, you can go to the www.energycodes.gov website, and there's a link to the COMcheck software. I'll note that there are two versions of COMcheck. We have our legacy COMcheck, which is the older code, and we have our updated, the new COMcheck, which I'll be giving the demonstration is. So the difference between the two is the legacy is no longer supported and has some of our older, you can still show compliance in older codes, but the more modern codes, the latest codes, are only exist in the new COMcheck. So you can see either one of those, and whichever works best for your compliance. They follow a similar workflow path. So knowing one, you could pretty much follow each of those codes, or sorry, each of those tools, and be successful. And then finally, on the same page, the energycodes.gov website, you can not only access the check tools, ResCheck and COMcheck, but there's other tools. There's the home energy score. There's the TSPR and others, the asset tools. So we have a significant amount of compliance software that could be used in addition to the check tools. But we also offers technical support, code notes, publications, resource guides, training materials. And the big one is our help desk. This is where most users of COMcheck and ResCheck will go to ask questions on problems in the software, how to enter something, or sometimes just code interpretations. So this is where it all starts right here. So with that, I will go directly into the COMcheck, and we'll start working through a building and give the high-level demo. So the first page, once you come to COMcheck Web, is the login page. If you don't have a login, you can register. And if you're like me, after a while you forget your password, we got you covered. So you can update your password here. So then once you're in, we can log in. And log in. There we go. And so the first landing page is the dashboard, the project dashboard. And there's a lot of capabilities here that I'll go through briefly. Is if, here, each one of these projects can be sorted and just ranked. So you can click to show different levels, last updated, the later or earlier versions. You can sort by energy code, status. Projects, there is the ability to share projects. And so I won't get into too much detail, but sometimes in completing a project, a COMcheck project, not just one person is entering all the data. There's an envelope, an engineer just entering the envelope information. Then there could be a lighting designer entering the lighting information, and a mechanical engineer entering the mechanical information. So there could be this could be shared between multiple entities, all putting in information into different areas of the software. So it would be just by clicking on this, and in your address book, you can select the person that you would share this with, and it would show that this is being highlighted as shared. Buildings could be imported from the legacy application. If you had a project there that you want to bring it over to the new COMcheck, you could import a project. You could export it if you wanted to. This could be that you just wanted to send a hard copy of the building file to another user, and then they could import it into their system and use it rather than sharing. That's a possibility. There are sample projects that we've created that can get someone who's new to COMcheck a starting point that they can build upon that project and create a full building. There's also, we can get shared projects. These are projects that have been shared by someone to me. So that's where those are listed. They don't usually show up in your main projects. These are projects that I have created myself. So we also provide a filtering button. So if you have, like me, I have 44 projects and I just need to filter down, you can do that as well. So just a little bit extra functionality to kind of clean up the dashboard and make it user friendly. So with that, to create a new project, we would just use the button up here, create a new project. And first you give it the importance of a name, for lack of a better one, building one. The location, very important. I'll give it to in Austin. So you could start typing in and it will give you options to select. And then again, the energy code. So I'll go with a 2024 IECC. And then the construction types, it covers, you can additions, new construction, and alterations. And with newer codes and energy credits, we have to specify, is this a corn shell? And then, asking about the HVAC systems, or if I want to do an alteration to cover a tenant build out, an initial build out, that's we could specify that. And then so the reasons for these is there's energy credits differences that are required based on what construction type there is. But I'll stick with new construction for now to keep it simple. There's these features are just informational. If you have all electric property, renewables installed, battery storage, EV charger, heat pump, just information that it doesn't affect. Sometimes some codes have changes in requirements based on if you have energy, renewable energy, or all electric or heat pumps are installed. So this is information that we could might be used on the code to help with mandatory requirements. For now, I will just enter his nose. We'll just keep it simple. And then you define the building area. So when you click on add a building area, these are all defined in the energy code, different building area types. So you can select one or a multiple and then hit add building area. I'll just keep it that we're adding one for simplicity and time, and give it an area. So I'll give it 20,000 square feet. And then the spatial conditioning type, is it residential or non-residential? And then for here, it specifies what's the lighting watts per square foot based on the code in the lighting sections. So this is kind of the minimum starting point. I've got my project, I identified, I got its location, which code am I showing compliance with, and what's the project type. These are the really important pieces, in addition to showing what building area and the area of that. And so now I can start going through and building. So as I mentioned that we have a top to bottom and left to right flow. So the natural flow is to first define the envelope, and then we can go into the interior and exterior lighting, define the mechanical systems. And then if renewable energy is required, in this case, 2024 IECC does have renewable energy requirements. So that shows up. If a code did not have, an earlier code is specified that does not have that requirement, this would not show up because it's not required. We'll talk about checklist requirements at the end, and then there's energy credits. Again, same thing. If an earlier code does not define energy credits, this would not show up. So it would be a shorter list to go through. And so starting with the envelope, we've defined the building area. It's an automotive facility. So when I click down, I see, okay, now I've got roof components, exterior wall, floor, and the basement. So in each one of these, whatever I have selected, I can hit the button, add an assembly, and decide add in any number of roofs or skylights. And just using these buttons to click. So right now, I'm just going to add one roof, and it comes in define. And then I can go to the exterior wall. I want to add one wall and one window. And for a floor, I'm going to add a floor. So this is really just a basic tenet. I'm defining the shape, really. Okay, so now I can go, once I've got this set up, I can go in and click for the edit. I want to define this actual roof. So I can give it, this is not, everybody can just give it, attic above, or sorry, let's just say insulation above roof, and select, this is the selection for that. And I give it an area, and then an R value, let's just say 60. And then I'm just going to say exemption applies for the cool roof requirements. But I might also, if I had that information, I could enter it within these radio buttons. And then when I apply this, it gives it the definition of the specification, and it gives it the U factor, calculate U factor based on the insulation. So I can go through the walls and do the same thing. You can edit the wall, enter the type of wall, give it a description, and within the type, I have to add in the properties of that wall. I'm not going to go through and enter each one of these because then it would just be taking too much time. And then the floor, same thing. I can enter a floor and then give it a type, enter in the characteristics, and it would show up here. I do have a fully built out project here, so it can show you similar. I've got my roof. I've got all my exterior walls, the gross area orientation, insulation, cavity and continuous, and U factors. I do have a window defined as the U factor, solar heat gain coefficient, visual transmissions, and the projection factor. And then the floor is defined as a unheated slab. So within this, I've defined my envelope. It's a very simplistic envelope. There could be more roofs, many more walls, many more windows, obviously multiple floors based on type. And then I can come and just see, I can check compliance. So I can come to the compliance screen, check compliance, and it will show me that right now, as it stands, my envelope is 20% better than minimum code. So I can see that that is something that it's good starting point for that. So I'll go back to this screen as we're entering. One thing I want to point out with exterior walls and roofs is the subsurfaces. So skylights or windows. When a window when I added the window, I have to assign it. It's an unassigned assembly. It's basically a floating assembly. It's not assigned to any surface. So I have to select it and then I assign it. There's only one wall to assign it to. Oh, sorry, I don't have if there is, so that's a good point here is that COMcheck does have logic checks where it will check to make sure that something is, like if this window is a larger size than the wall, it won't transfer. It'll give you that warning where right now I have a window has 0 area, so there's nothing defined, so it's not allowing me to do that. But typically when I have the information, I can assign that to this wall. And like this case, in this project, I've assigned a window to the south wall. So that's where it sits. I could move it, I signed it to the wrong wall. That's silly me. And now I can assign it to this wall. So you can change it around. You can edit any surface. You can also select this box. There's actions items. You could duplicate a wall. You could delete it or edit it. So there are, in addition to just adding another assembly, I can go in here and add another wall, and up here in fenestration. So with fenestration, there's buttons up here, I should say, that there's fenestration requirements. This kind of gives you what are the requirements for fenestration for this specific code for the 2024 ICC. So it's just a little information that you can use, just like if you can't remember what's in the code, it provides that information. The code provides daylighting allowances. So if you select these and saying there is daylight in this building, there's a difference between what's the minimum required window to wall ratio or skylight to roof ratios that are allowed for the compliance. So that's what the daylight allowance for. And always in every screen, you could check compliance. And then up here, it gives you kind of a screening of what's the status of the compliance of the envelope and other components that we'll walk through. So that's kind of a quick review of the envelope and how to show compliance there. The next step is interior lighting, and it follows a similar path. So we have our facility defined, and so what we're we want is before any lighting is specified, you go through and build a fixture schedule. So in here, this just lists all the fixtures that will go into the building that you can assign to a space. So in my case here, I've just got 2 lighting fixtures specified in my fixture schedule. And I build this out by just simply adding a fixture. There are fixtures in a library that are attached to my account that you can build and select from. And I have 3 of them in my library, but I can select from there. There's also a template. You can download a spreadsheet template and build that out and then upload it, and it will supply this entire fixture schedule really quickly, one button click. So there's multiple options to build this lighting schedule. So once this schedule is built, like I've done here, I can add a space, and this is out of the space by space method in the code, that you can select a room and give it an area, and then determine, is there any primary or secondary or any kind of daylighting area within this space? I'll leave it none. I can add the fixture. So now it pops up my fixture schedule. Which one of the fixtures from this schedule do I use? And I can add it to here, and then to determine the quantity. And then go to the next screen. That there are exceptions or allowances. I won't get into that. There's a lot of, so the exemptions meaning if this this space has an exemption for this fixture. So I can identify the fixture, but I can supply one of the many exceptions if it applies, or an allowance if, and for display or lighting, you can set up a different allowance. It allows more lighting for the space. So if there's none there. And the next is just listing what controls are part of this. This COMcheck is not checking mandatory requirements for controls, but just asking for what controls exist in the building. And so you can select that. And then finally add the space. So there's another space added here, a secondary space. And then COMcheck is checking, calculates the proposed wattage. Here's the proposed wattage of these 2 spaces. And then what's the space, and what's the allowed wattage by space and building area. So it's running 2 compliance methods here. There's always, in all codes, there's a building by area method and a space by space method. So real shortly, when we defined the project and it's an automotive facility, that's the one building area that we've defined. So that has the, at 20,000 square feet at 0.73 watts per square foot, that's the allowed wattage that you get for the building area method. And for the 2 spaces I've identified, this is the allowed wattage. So COMcheck is going to look at what's the best. Does it pass one or the other, both, or none? Compliance will run on the better performing methodology. So that's lighting in a nutshell. For exterior lighting, it will run off the same fixture schedule and follows a little different methodology. So for the zone of needs to be identified, which is kind of what kind of zone is this building located in? Is it a residential zone, mixed use, neighborhood business district, on and on, for a developed area, a rural area? So depending on where this building is located, you select the appropriate zone. And then from here, that zone determines what is the allowable wattages and what's required. So from here, you can, same thing, you can identify an area. So we've got the zone, just now adding a building exterior, the exterior lighting piece. And so straight out of the code, it lists all the different possible areas of exterior lighting, from landscaping, driveways, parking, pedestrian areas, sales areas, stairways. So any one of these, whichever one you're identifying where there is lighting, you can select. So for this case, you can say a loading dock, you give it a quantity, what's the square footage there? So 2,000 square feet. Again, you add the fixtures. I'll use the 6 watt LED, and get, just there's 10 of those fixtures. I have no exemptions. And then same thing, specifying the controls that exist for this lighting, the exterior lighting, and then I can add this area. And so based on this, it's a similar down and below. We're showing that so there's I'll have to back up and kind of explain so for exterior lighting, there's based on the zone that's been identified up here, the zone, we're zone 2, there's a base site allowance of 280 watts. And so based on these entries, there are tradable and non-tradable wattage. So we've just selected 2 tradable pieces. This means I can trade back and forth between these 2. So one might be above this, the allowance. This one could be below it, but I could trade them off. So as long as the total is under the allowed amount, I can trade those across each other. Non-tradable wattage is defined by the code that it's a non-tradable item. And I think one of those is a ATM, if I'm correct. So say there's one ATM machine. Got 2 fixtures. Okay, so now here, so now we have a non-tradable. So that means that area has to be met, and it can't be traded with other fixtures. And so COMcheck is going to look at the base site allowance, what's the tradable and non-tradable watts, and then do we meet the total allowed wattage? In this case, we do. We're quite low, or below the minute. So COMcheck is doing all that logic behind the scenes in the engine to verify that tradable is allowed to trade across each other, non-tradable is not, but does it all come together and meet the intent of the code? So similar with the envelope, I can go back and check compliance, and my exterior lighting looks good. Looks like I've entered too much area for the interior lighting. So that's one of the things I mentioned. COMcheck is going to do a lot of logic checking, and what it's saying is, I've defined my total building at 20,000 square feet, but I've added an extra 1,000. So it's saying you got too much area of lighting above. So I'm just going to delete this. Now, okay, so now my interior lighting is showing compliant, my exterior lighting is showing compliant. So far so good. We're looking good on our design. And now, so we've got project, envelope, interior lighting, exterior lighting. Now we can go to mechanical. And so with this project, with this system, with this area of COMcheck, there's multiple system types that we can add. We can cover HVAC systems, fan systems, plant equipment, and water heating. So each one of these has a wizard logic that helps you flow through the inputs. So I'll start with HVAC. So when you add a new HVAC system, you can give it a name and then determine first, is this a heat pump system? And if it is, then it gives you a list of heat pump types to select from that are based on the code. Or if not, then just kind of more of a simple system here. So I'm just going to select, okay, so I have a central furnace and I'll just say, so here, this is listing all the cooling equipment as well. So depending on which system you have in the building, for here, I'm just going to pick a split system DX unit, and I go to the next screen. And here, it can outline where you are in this, and you could go back and click on the. We have to fix this part, and I've noticed this. You could go backwards by clicking the buttons, but you can't go forward, and so something we'll need to correct. But yeah, you could see where you are in the process. So I've got a central furnace and split system. So I can give them names. It's not necessary, just for organization. And then specify the fuel type. So the furnace, I'm going to go with natural gas. The condenser could be air cooled, evaporative cooled, or water cooled. So I'll select air cooled. And then the quantity, 1 or more, whatever exists in the, and then the capacity. So, enter the capacity in kilo BTUs. And then, so from here, COMcheck, based on the system type and the capacity, there's efficiency requirements. And so as you start entering the proposed efficiency that you have, as you enter it, it's going to show you what is the minimum efficiency for this specific equipment. So in this case, I want to say I've got a 90% efficient furnace. And then for the IER for this system, it requires 14.6 IEER. I'll give it 15. And again, like if I change the capacity or the system type, these efficiency metrics would change. And one of the things COMcheck will not do is equipment that is covered by DOE regulations are not can be entered in COMcheck. COMcheck is not going to check the efficiency because those are minimum efficiencies. So the equipment would not be lower than that efficiency. So when these are systems entered, these are efficiencies not regulated by DOE, but covered within the energy code that have specific efficiency requirements. So once I've specified the capacity and efficiency, I can go through and create a fan system. So the fan system, I can just give it a name, fan sys 1, and decide, do I want to check on its motor nameplate horsepower or its brake horsepower? So I'll start with motor nameplate, and here I can add a fan. I'll just say I'm going to add in a supply fan. There's multiple types. You can do a supply, return, relief, exhaust. And then fan control, is it constant or VAV? And the volume, I'll just say it's 10,000. I'm really bad with CFM and horsepower, but I'll just give it 1.5. And then this should be fan energy index, but this will give it a 1.02. And then there's also FEI exceptions. If they're met, you can select one of those and not have to enter the FEI. But then once I've got this set up, I can complete my fan and then select it for this project. And then go through, I can select single zone. If I select multiple zone, there's additional inputs I could verify. And these specify which requirements this project must meet based on these inputs. So it adds how you can specify what types there are. And then finally, finishing with the economizer. Let's say it's air economizer. And then kind of a similar, added a secondary system that meets, checking that it does meet the efficiency. The proposed is greater than the part load or the required efficiencies. So this shows the two fan systems I've entered that we just walked through. I entered one before, but the second one. And the plan is very similar. You can add a boiler or cooling plant and heat pump chiller, and it walks you through each, through the required inputs that just, based on the chiller type. Is it, what's the condenser type? Is it, the different chiller types? And then you can specify the capacity, full load or part load efficiencies, not quantity. And again, and then with chillers, there's path A or path B efficiencies you can specify. And it will show you, based on the design of this chiller, what are the required full load and part load efficiencies. So it just walks, the COMcheck is trying to be user-friendly and walk through what's needed for each one of the, to fully define the chillers, so that we can check, COMcheck can check the mandatory requirements. And then similar with water heating, you can enter a storage or instantaneous water heater. And then there's, you can define additional equipment that are attached to this water heater. Does it have a circulation pump? Is it for a swimming pool? Is it a combination system? Is there heat trace as part of the system? Which each one of these selections and all the inputs triggers different requirements that COMcheck will check for, or provide a checklist item that for the code inspectors. And then again, so define the quantity, what fuel type, what size is the storage, and then the input rating. And the efficiencies change from thermal efficiency to UEF based on, the inputs that are shown. And so then once you've identified it, it'll show up here. And in this case, I entered a gas storage water heater, and it required 0.78 UEF, and ours is 0.82, so it meets the requirements. So there we have kind of the inputs, the envelope, interior lighting, exterior lighting, mechanical. And so renewable energy is just, it's a simple input of, okay, so this code 2024 ICC has a renewable energy requirement. And if the building meets any of the exceptions, it could not require it'll just say, let me back up on the ruling. So if the 2024 IECC states that if an exception is for on-site, because there could be an on-site or off-site renewable energy requirement. And I know this is overlapping a bit. I'm going to try and hopefully this isn't too small for everyone to see, but I don't want to get any overlap. So we have the on-site requirement and then the off-site requirement. So if an exception is determined, then there's still an off-site requirement for this building. So we have inputs for on-site renewable and off-site renewable energy. So if there's no exception, then it's expected that a system would, and I know this is, let's see, okay. So I have no exceptions. And then that comes into play is what's the number of floors in this building? So there's a ruling that the area of the 3 largest floors usually dictates if the building is over 3 floors, then the area of the 3 largest floors determines the amount of renewable energy that's required. But if it's less than 3, then it's just basically the total building area, which is the 20,000 square feet. So the requirement based on that is 15,000 watts of on-site renewable energy. So in this system, I entered 20,000, so that meets the requirement. If I could also meet this with a combination of off-site and on-site renewable energy. So if I had less than 15,000, I could supplement it with off-site energy to meet the requirement. So I could go to the compliance screen and check. And it says, because I have the 20,000, my renewable energy passes. So that's fairly straightforward. The code is complex in that in 90.1 2022 has just on-site requirements, where 2024 has off-site and on-site and off-site requirements. So it's a little tricky. COMcheck follows all the logic of the code. Sometimes it's confused. This is where we get a lot of help desk questions, because it's depending on what combination you have, it may meet, it may not beat the required amount. So it's just COMcheck's doing the diligence of checking following the code. And then the final piece is of the inputs is the energy credits. So this, there's way too much to go into, but this covers, for the 2024, this covers all the envelope credits. I'll unselect that. The lighting credits, all the HVAC credits, and then there's service water heating energy credits, miscellaneous energy credits, and the renewable and load management energy credits. So at the top here, there's requirements for 2024. There's required energy credits, and then there's renewable and load management credits. And so there's required credits from each category. So for this project, I need 90 credits for this set of renewable just from this section, and then from the rest, I need 58 credits from these select ones. There is allowance that you can trade, that if you exceed the renewable and load management required credits, that they could be applied and reduce the energy credits of 58. So COMcheck will do that checking here. So when you select different credits, there may be inputs that are asked for. In this case, I imagine on your screen, this is very small. This is a percentage lighting load management in percent. So I'm saying all my lighting has load management. And then there's a button here to calculate energy credits. And there we go. So credits show up based on the inputs. And up here, it's going to show that I now have met my renewable and load management credits. And as I mentioned, since I'm so far exceeded these credits, it's reduced the credits for my normal energy credits that I need to obtain. So it went from 58 to 53. So let's see if I can add a few. Envelope, I won't do this in the sake of time, but energy, the EO1 energy credit for envelope requires an Appendix C simulation. So when this, if you select this, you can do the envelope calculation, and this will run an Appendix C simulation. It usually takes a few minutes. I want to spare some time. But otherwise, you just use the calculate energy credits button. So we had to separate these two out just to verify if I'm selecting the EO1 energy credit, and that's why there's a message down here, and I know it's probably small. Let's see if I can get it bigger. It just says use envelope calculation button top right to calculate energy credits for this measure. So then we can select that, and it will show the credits if it meets them. And so I'll say this, that there's the envelope C simulation for the envelope, and then there's the envelope C, then there's the Appendix C simulation for energy credits, and the windows in the baselines are different. So a lot of people will see, wow, my building envelope is 20% over the code, but I'm not getting credits for this. And typically what we found is if a project has a lot of window to wall ratio, that's, you know, the baseline building will have the maximum. So it could be 30% or 40% based on the daylighting. But for the Appendix C for energy credits, that the baseline window area comes from Appendix G, and those are low. So that means your baseline building is going to have more stringent, it's going to be less window area, so it's going to have lower, you know, typically a lower load and lower consumption. That makes that the energy credits comparison for the Appendix C, since your baseline has lower window area, it makes it tougher. And so sometimes you can show savings on the code, but the credits shows zero. So something to kind of look at the details in the Appendix C. It's under how the building performance factors are calculated. There's a snippet on energy credit for the baseline building. So a lot of detail, but anyway, so let's see if I can get enough credits for. Okay, I'm good here. So I've got 74 for the required credits, 175. So when I go to compliance, it shows the totals I proposed are both above my required, showing my pass. So I've got, everything's looking good. I've passed everything. The final step is the requirements. So in each section, so when I go to envelope, interior lighting, exterior lighting, at the bottom, there are the controls, the mandatory requirements that need to be, that are code officials want the user, the people entering the building to verify, to say, hey, the plans are, you know, in this case, and that's very small. If I can make it bigger. So this is a requirement for plan specifications and construction documents to encapsulate all the lighting information. And I can say lighting requirements to be met, and I need to enter, you know, any text will work, but it wants, you know, where in the plans can I verify this information, and it shows the green checkbox. So the idea is the user will go through each one of these and verify, either say the requirements will be met, there's an exception, or this requirement doesn't apply. You know, and sometimes in our logic in the COMcheck, we put out a requirement that might not be applicable to this building. And so there's always an option that this does not apply. And so the idea is to get all the checkboxes green and then compliance can be had. So that's the idea. We don't hold hard to that requirement yet, but in the future, we may just, if all these aren't identified, we won't show any kind of compliance. So like I said, for each one of these, there is, you can go through the requirements section by section, or you can come to the requirement tab and it will have all of them in one location that you can go through and address, that the user can go through and address each one of them, and then be done and show the compliance. So finally, within the compliance screen, we've checked compliance. We've got everything's passing. And one final thing I'll say about compliance is envelope we've talked about, it has either the UA compliance or, excuse me, the Appendix C simulation compliance. Interior lighting, you can do either the building area method or the space by space method. Exterior lighting has its compliance methodology for looking at allowed power. The mechanical, if you're looking at mechanical, doesn't have a general compliance. There's no method in the code that says mechanical complies. It's each system has its own requirements. I apologize. And so that's why there's no mechanical compliance in here. It's checked within each system, each component, and verified in the report. So having said that, within the compliance, there's the reports that will generate. And I'll pull it up here because I printed it out earlier. So here, you're going to it's going to reply all the compliance information that was entered, location, code, size of building, any of our, additional information we entered. There could be the construction. This is additional information we didn't enter, but could be entered within the project screen. And then it goes through, excuse me. And so lists all the energy credits we selected. And it's showing that we beat. The green bar means that we've passed the energy credits. It shows the renewable energy inputs and that the renewable requirements haven't been met. Showing the building area. I've only entered one building area, but there could be multiple building areas to the project. And then we have, so getting into the components, envelope compliance certificate. So showing all the assemblies that I've entered, the area, insulation, shows proposed U factor, and then what's the budget U factor. So how do I compare? So this could be used as a, if you're not passing, look at your components, excuse me, and determine, why am I not passing? Oh, my walls have a terrible U factor. Maybe that I didn't input the insulation correctly. So, and then finally, a green banner showing that the envelope didn't pass. And then the compliance statement where it could be signed by the input person doing the inputs. And then there's interior lighting compliance certificate. So it's going to kind of mirror all the inputs you made. And then the controlling the power, the controls, and that you've met the power requirements for the system. Same thing for the exterior lighting, mirroring the inputs and kind of showing the tradable and non-tradable wattages. And then just, summing them up based on the base side allowance, total watts, and then lighting controls, and then the compliance statement. So it's showing, okay, that this did meet the compliance. And then the mechanical side, again, there's no banner to show general compliance. It's just going to show, that if something failed, it wouldn't show a failure message, but this is just showing that everything is meeting the requirements. The efficiencies in the proposed building are higher than the efficiencies. So if I had an efficiency lower than what was required, this would say this fails compliance. So it would show the code official or the plan reviewer that this did not meet the minimum requirements. And a place to sign. And then the final piece is the inspection checklist. So this goes through, based on all the inputs that were made, what are the requirements that need, and so then these need to be verified in the field by the inspector. So it flows through by phase of construction. So the first set is for plan review requirements. And then footing and foundation inspection, what requirements are for that phase?
Hey, Rob, we have
Yeah.
5 minutes left for a Q&A here.
Perfect.
I
Oh,
just figured
goodness.
I'd give you a heads up.
Okay, let's do it now. And so, yeah, it just goes through the different phases and mechanical, and then pretty much final. So let's go. I'll finish there, and if there's any questions, I'm sorry about that.
No worries. Thank you, Rob. That was great. Yeah, we have our cameras on, so yeah, I'll hand it over to AE Robert to go ahead and walk us through our QA. And just a reminder that anything we don't get to today, go ahead and still leave those questions in the Q&A box, and we can answer those in our follow-up email. Okay.
Yeah, if you have any questions, put them in the Q&A box right now. We do have a couple questions. As a reminder, we will be sending out a follow-up email with a recording of the presentation and links. So if you want to revisit something, we will be sending that out. Rob, I'm going to start with you about the scope of COMcheck versus ResCheck. For example, a multifamily building, if it's a residential permitted building, when would you use COMcheck versus ResCheck? Do you use COMcheck in the common area and ResCheck for the units, or when do you use which software?
That's a good question. Well, first off, if it's a low-rise multifamily, 3 stories or below, ResCheck can be used. And so, but if anything higher than that, it's COMcheck. But to that point, if there is a high-rise, mid-rise multifamily that has very clearly delineated residential and commercial portions, then ResCheck could be used for the residential component areas, and COMcheck could be used for the commercial areas. So code official has the final say, but typically we found that can be allowed.
Great, thanks. Chris, I got a question about working from home. Have you seen any changes in Manual J guidance based on people working from home or doing things at different times of the day, like cooking in the middle of the day or doing laundry in the middle of the day? Has there been any kind of changes?
So no, the process allows for this, and it's been in the system design process forever. What we have to disassociate is the size of the system from how we zone the home and how we address comfort in those spaces. We have to make sure we're allotting for, my home office that has all of these pieces that are giving off a bunch of heat, right? That's gains. But if I want to be comfortable in this room versus the rest of the house, I probably need to zone this room with a separate piece of equipment. And I saw another question very similar with like elderly that wanted a certain temperature or something along those lines. The same thing applies. If you have a zone that requires more critical temperature requirements, then that should be zoned in the house. But we're still sizing following Manual J.
Thank you very much. And also, Chris, how closely do real building results match the Manual J predictions or calculations? Sometimes there's contractors that feel that the Manual J calculated size is undersized or too small for what their professional experience says it should be. Do we know about how Manual J addresses?
Yeah, if you do an aggressive load calculation, you're going to be at least 20% too big. So the gut feeling and somebody's professional experience, I hate to be the bearer of bad news, that's probably square foot per ton or some sort of rule of thumb that you've used in the past. And just because you haven't had callbacks does not mean it's not oversized. There's no silver bullet for oversizing. And, a system doesn't ramp down to 1 BTU. So you're going to have low end problems when you oversize a system under the majority of the low load days. So yeah, if you do an aggressive load calc, it's too big. So therefore, if you're using rule of thumb and it means something bigger, it's even larger.
Thank you so much. We did get some more questions in. We'll try to follow up with you afterwards. We are at time. So Elliot, do you want to take us out, please?
Sure. Yeah. Thank you to everyone for attending. Please take a moment to complete the survey link placed in the chat. Your feedback is greatly appreciated and helps us plan future webinars. As a reminder, everyone registered will receive a follow-up email with resource links and the webinar recording. Today's webinar attendees will receive a continuing education certificate for self-reporting GBCI CE hours and AICP CM credits. If you provided your AIA number during registration, we will report your AIA learning units for attending this webinar. If you couldn't attend the entire webinar or want to share this information with colleagues, this seminar will also be added to our e-learning platform in about 3 weeks, where you can watch the recording, take a quiz, and earn CEUs. Check out the current courses at this link in the chat and log in to get started. Thank you all again, and this concludes our webinar.